we'll go on from there. Okay, this is a review of the last type of questions we had done on Tuesday, called a conic section. I noticed that the equation is a quadratic equation where it has both an x squared and a y squared term. Now, that will tell us right away that this is not a parabola, because a parabola only has x squared. It doesn't have x squared and y squared. It doesn't have a y squared. It's not a circle because the numbers in front of the x squared and the y squared are different. They're not just plain 1x squared plus 1y squared. It doesn't matter what else is written there. That's what we look at, the x squared and the y squared terms. This happens to be an ellipse because we have an x squared plus a y squared term, but the coefficients in front of the x squared and the y squared are different. And if you remember, the way we put this in standard form is, first of all, we have to have it equal to a number. So I'm going to add this 100 and put it on the other side, so that we will end up with 25x squared plus 4y squared equaling 100. And then we'll have to divide everything by the 100 because we really want it to be equal to 1 on the right side. So I'll have to divide this by 100 and this by 100 as well. And we reduce this. The 25 goes into the 104. Notice the 4 is in the bottom because the larger number is in the bottom. So this becomes x squared over 4. And here the 4 cancels into the 100 and gives me 25. So this is plus y squared over 25 equals 1. And now it's very clear that this is an ellipse. And in this case, the a squared is the number underneath the x squared is 4, which means my a can be either positive or negative 2. And the b squared, the number under the y squared, is 25, which means my b is either positive or negative 5. Now remember, the a's and the b's are what gives you the x and y intercepts. The a's are the x-intercepts, the b's are the y-intercepts. So if I go to graph this, my x-intercepts are either positive 2 or negative 2. So that's this. And my y-intercepts are either positive 5 or negative 5. And if we connect these with a curvy line, we get our ellipse, our oval shape, and that's what we have to know. Remember, the vertical, in this case, the vertical axis is the major axis. It happens to be 10 units long. The minor axis is 4 units long because it's going from one end to the other. And in this case, the minor axis is along the x-axis. We talked about this. If there had been a minus here instead of a plus, this would have made this a hyperbola. A hyperbola has a minus between the x squared and the y squared term. Okay, so this is where we had left off with our conic sections, and then we started talking about right triangles, and that's where we're going to continue right now. Just before I do continue, let me mention the chapter we're doing now, trigonometry, is not in the textbook, but if you look in your weekly folder on CUNY Blackboard, on your Blackboard account, in your weekly folder, you will see a trigonometry handout there, number 1. Number 2, also in your weekly folder, you'll find a review sheet for problems from the department that covers the second half of the term since the midterm. And also what I call my Math 136 study guide, which is something I made up that has all it was going to look something like this. Let me show you the front page. Going to get something that looks like this. It says study guide for Math 136, and it covers all the material that we covered this term, including the important formulas and examples of all the different types of examples that we've covered over the term. So it's a very good review for you for the final exam. The final exam, we're up to class, I think we're up to class 23. We have a total of 28 classes, so we have just after this 5 more sessions. I think our final is the week of December 12th, sometime during that week. I don't know exactly. I'll have to get the exact timing. It'll be more specific times, like I'll probably give you, it may be given either in the morning or the afternoon, depending on when they told me to give it. It will be at a time when I will be available to proctor it for you, so that if you have any problems with your internet, that's the only thing I can do for you, is if your internet goes down, I can restart the test for you. Other than that, it's going to be very similar to the midterm. It's going to be 30 questions, not just 20 questions. There's going to be 30 multiple choice questions from material starting at the beginning of the term. It's not just from the midterm on, it's from the beginning of the semester. I will be posting in a little bit, in a week or so, a practice final, which I'm going to do the same thing. I'm going to count it as a test for you. So at this point, what you should be doing is preparing for the final by reviewing the different types of questions that you might encounter. Again, this study guide is a good preparation because it gives you formulas as well. It gives you all the formulas you need. The review sheet is also good because it's tons of problems there. And with each of them, I did include an answer key so you can check your answers. There will be homework on Delta Math. At this point, you should be finishing up, making sure that if you're missing any homeworks or any tests, that you make them up at this point, because anything that's missing will count against you. In terms of homeworks, even what counts is if you tried the problem set. If I see that, if I look at a problem set and I see you got a 65 on it, but I open it up and I see you tried all the problems, it's just that you got a few of them wrong, you'll get complete credit for doing the homework. You do not have to get every problem right on the homework to get credit for it. The final will be similar to the midterm. It will be on Blackboard. Again, there's probably going to be one more test on Delta Math, but there will definitely be a test on Blackboard, which will be a prep for the final, and the final exam is also given on Blackboard, very similar to the midterm. Does anybody else have any questions? Yes, the final is multiple choice. Just the way, okay, so I think with that, all that said, we can go on to the next topic that we're going to be talking about. And that's right triangles. And we actually talked about we actually had talked about a very important formula or theorem that we use with right triangles, which is called the Pythagorean theorem, that a squared plus b squared equals c squared. What we did is we drew a right triangle. And usually with a right triangle, we label our points, our vertices A, B, and C. This one with this square corner, that's our right angle. That's how we indicate a right angle. We use capital letters for the angles. We use lowercase letters for the sides. So, and we do it very specifically. This is my A, so across from it is my small a. This is my capital B, so across from it is small b, and across from the capital C is small c. In this case, since C is a right angle, side C, the small c, is what we call the hypotenuse. The other two, the A and the B, are the legs of the right triangle. And what a squared plus b squared equals c squared tells us is that if you take each of the legs and you square them and add them, that'll give you the hypotenuse squared. This only works in right triangles. So if I were to tell you that I have a right triangle and I know that side B is 8 and side C is 17, I could ask you to find what side A is. This is a right triangle, and this is the picture they gave me. So C is my hypotenuse. This is my A is what we're looking for. And the B we know is 8. So I can use my Pythagorean theorem, a squared plus b squared, well, that's 8 squared, equals c squared, that's my 17 squared. And this gives me a squared plus 64 equals 17 squared is 289. And now I have to subtract the 64 because what they gave me was the hypotenuse. They didn't give me the A and the B, they gave me the B and the C, and they asked for the A. So this gives me that a squared equals 225. And then I either go to my calculator or I know the number. I have to find out what A is. I have to take the square root, and I get that A is 15. Notice in this case, we only use the positive square roots because we're talking about how the sides of a triangle, and the sides of a triangle can't be negative in length. They only could be positive. So it doesn't make sense to use negative answers. We then, and this is what we had finished last time. So this is where I want to start now. And this is where I want to start. Notice what we've learned is that if we have a right triangle and we know two sides of the right triangle, we can always figure out the third side. This information didn't help us with figuring out the angles of the triangle. It just helped us figure out the sides of the triangle. Now, let me just make one other comment. Sometimes instead of, usually we use capital letters for the angles. Sometimes you'll see a letter that looks like this, or a letter that looks like this, or like this, used with trigonometry. The most common one being this one over here. It is a Greek letter. This is the Greek letter Theta. It's pronounced theta. It's like the most common letter used in algebra from the regular alphabet is X. The most common letter used in trigonometry, that's a Greek letter, is this Greek letter theta. This happens to be an alpha, this is a beta, those are other Greek letters. Very often in trigonometry, Greek letters are used. And this is just because traditionally, the Greeks were the ones who were so instrumental in developing the whole concept and study of trigonometry. So very often, instead of using just A's and B's, they use these Greek letters. One of the advantages of using them, the only really advantage that I can see, is that you only use those Greek letters to represent angles. See, sometimes when I say, oh, look at angle A, if I don't write it out, you might think is A an angle or is A a side? Now, we're very careful. When we use capital letters, we mean them to be angles. When we use lowercase letters, we mean them to be sides. But look at C. Capital C and lowercase c look very similar. If you're just writing this out and I say, look at C, you might not know, do I mean look at angle C or do I mean look at side C? But if I say, look at theta, and I use this symbol, there's no question about it. You must be looking at an angle. So that's the only advantage. So sometimes I'll call this angle A, sometimes I'll call it angle theta. It's just a name. Okay, Maury, did you have a question? Okay, now, as I said, the Pythagorean theorem, this formula that we're using, tells us how to figure out sides. It has nothing to do with angles. When we want to talk about angles, that's when we go to trigonometry. We can't forget this because it will be helpful, but let me show you what we're going to do. We're going to talk about today three principal I think it's actually on. When I mean principal, I mean main. I'm not sure if I'm spelling it right. Three principal trigonometric values. I'll call it trig values. There actually are 6 that we're going to be talking about, but today we're only talking about the first 3. We're talking about something called the sine, which we abbreviate SIN. The second one is something called the cosine, which is abbreviated COS. And the third one is what we call the tangent, which is abbreviated TAN. If you notice, we're just using as the abbreviation the first 3 letters of each word. And if you look on your calculator, we have a regular scientific calculator, you will probably see 3 buttons, one that says sine, one, I'm not going to call it sin, I'm going to call it sine, one that says cosine, and one that says tangent. And we're going to, by the end of this period, you'll know what these 3 things stand for and how they're going to help us with figuring out triangles. Each one of these values is actually a fraction. It's a fraction of one side divided by another side. So let me give you let's draw a right triangle. And let's see how this works out. Let's say I have this angle. Let's call this angle theta. If you want to, you could also call it A, B, and C. And let's give some values to this. Suppose this side is 3, this side is 4. And let's figure out what the third side of that triangle is. I'm going to give you a minute while I take attendance. I'll be taking attendance now, but I want you to figure out what is the hypotenuse of this right triangle. Shouldn't take you very long. Okay, Maury, I know you're here. Chelsea.
Present.
Hi. Ariana.
Here.
Hi. Adina.
I'm here.
Hi. Lachey.
I'm here.
Hi.
Hey.
Kava, I know you're here because you were here right. Number 1.
Yeah.
Terrence Cruz.
Yeah.
Hi. Karide. Karide here. Kizia.
Here.
Faith. Ethan.
Here.
Hi. Isabella. Serenity. Reggie. Reggie,
Here.
I know you're here. I saw you before. Zamia. Brandon.
Here.
Hi. Michaela.
Here.
Hi. Seraphine.
Here.
Marissa. Renee. Hi. Sky. Hi. Jaden Roberts. Kennedy. Felicia. Okay, Kennedy's is, I'm going to mark her present then. Thank you, Kava. Felicia. Natalia. Hi. Michael. Cassidy.
Here.
Hi. Megan. Kalia? Lauren?
Hi, I'm here.
Hi, Lauren. And Kayla Zachary. Okay. Let's go continue with this. Okay, the first thing I told you to do is I wanted you to find the third side of this triangle. Now, I didn't label it A, B, and C, but it's obvious the side that I'm asking you about is the hypotenuse. It is the third side. So I would do my 3 squared plus 4 squared equaling C squared. And this is 9 plus 16, which gives us 25. So that C squared equals 25, which means that our C has to equal 5. The third side of this triangle is 5. This doesn't usually happen, that all 3 sides come out to be whole numbers. This is what's called 3, 4, 5 is what's called a Pythagorean triple. The A squared plus the B squared equals the C squared. We had another Pythagorean triple just before, 8, 15, and 17 was also a Pythagorean triple because 8 squared plus 15 squared gave us 17 squared. What usually happens is that one of the answers comes out to be either a radical and with a radical sign or in a decimal. That's the more common situation. Okay, so let's look at this. We now have all 3 sides of this triangle. Now, first of all, these 3 values that I'm going to be talking about, well, I'll never just say find sine. I will say sine, and next to it will be the name of an angle. Okay, I'm going to mark you here, Alicia. So I will say something like find sine theta, or find cosine theta, or sine tangent theta, because these values really are connected to the angles of the triangle. They have definite meaning in terms of the angles. Now, if I look at my triangle the way I drew it, and I look at angle theta, there's one side that's directly across from the angle that I'm talking about. That happens to be this. We call this the opposite side, or the opposite leg. Leg is more accurate term. Of course, the side that's across from the right angle is always called the hypotenuse. And the hypotenuse is irrespective of what angle you're talking about, because it only depends on the right angle. The third side of the triangle happens to be connected to my angle theta as well, just like the hypotenuse is. It's right next to it. It's called the adjacent side. And that's the first thing I do when I'm interested in figuring out trigonometry. I look at the angle that they're talking about, and I'll know which angle they're talking about because it will say sine, it'll give a name of an angle, or cosine, or tangent. It will mention the name of the angle. You will then go to your triangle And you will look at your triangle, and based on the triangle and the location of the angle, you'll be able to tell which side is the opposite, which side is the adjacent, and which one is the hypotenuse. What's so important about it is because of the meaning of these three trigonometric functions. The sine, each one of these is a fraction. The sine happens to be the fraction that you get by putting the opposite over the hypotenuse. The cosine is the fraction you get by putting the adjacent over the hypotenuse. And the tangent is the fraction you get by putting the opposite over the adjacent. As I said, each one of them is a fraction. Now, sometimes they're not written as fractions, sometimes they're written as decimals, because any fraction you can turn into a decimal. Let's figure out what the sine, the cosine, and tangent is for the particular example that I'm talking about here. The sine of theta, for our particular case, is the opposite. Look at it, I've already got it labeled, so it's easy to tell, is 3 over the hypotenuse, 5. 3 divided, so 3/5 is my answer in fractions. If I go to my calculator and I do 3 divided by 5, I get it as a decimal, so I could also use the decimal equivalent. For each one of these, sometimes we write it as a fraction, sometimes we write it as a decimal. The cosine of theta is the adjacent over hypotenuse. So for our particular case, here's my theta. The adjacent is the 4, and the hypotenuse is the 5. And 4 divided by 5 on your decimal, on your calculator, will give you 0.8. The tangent of theta, we said, was opposite over adjacent. So in our case, it's 3 over 4. If we change it to decimal, we get 0.75. If it doesn't come out to an exact decimal, we round off to 3 decimal places. That's generally the accepted method. You could do 4, but you don't just do 1 or 2, you do at least 3. So each of these things, the sine, this cosine, and tangent, is a number. By the end of the class, I'll show you the significance of the number, but first, before we figure out what to do with them, we have to figure out how to get them. If you notice, the sine and the cosine are always have the hypotenuse in the denominator. The hypotenuse is always going to be bigger than either of the legs, because the hypotenuse is always along the side of the triangle. It's that, like the ladder, it's the one that goes on an angle. So therefore, the sine and the cosine will always be numbers less than 1. They'll always start in decimal form with the decimal first. The tangent sometimes is less than 1. It just starts with a decimal, and sometimes there's a number in front of the decimal. You can't tell what's about the tangent. But the sine and cosine are always start with a decimal point. That's why we want to go to at least 3 decimal places. What's the hard part about this? Well, the hard part about it is remembering what is the sine, what is the cosine, and what is the tangent. So there's this rather famous what we call mnemonic device, a way of helping us remember it, which is called SOHCAHTOA. Now, I remember this word SOHCAHTOA by picturing in my mind somebody coming and freezing from the outside. He's been in the cold snow and his feet are freezing. So he goes inside and he puts his feet in a bucket of water, of warm water, and he's SOHCAHTOA, he's soaking his toes. That's how I remember what the statement says. Remember what a mnemonic device does. It helps you remember. What does the SOHCAHTOA tell us? It tells us that the sine is opposite over hypotenuse. You got to have it spelled right. The cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. You have to know what they stand for. The sine is opposite over adjacent. The cosine is, the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. The tangent is opposite over adjacent. Okay, let's see if we can do, I'm going to do another problem with you where things are set up a little bit differently. And let's see if we can find out the sine, the cosine, and the tangent. The sine, the cosine, and the tangent are what we call the three principal trigonometric functions or values. As I said, there are three others that I'm not going to be discussing today because I think it's going to be too many words, but that's what we're going to talk about on Tuesday. By the way, next Thursday, I'm sure everybody noticed, is Thanksgiving, so there's no class on Thursday. Next week, we only have one class, that is on Tuesday. Okay, so I'm just going to leave that SOHCAHTOA on the board. And I'm going to put another problem on the board. I'm going to do two problems now, and then I'm going to give you one to try. First problem. Here's my right triangle. And here's where I'm calling my theta. Be careful. It doesn't always sit the way we think it does. Okay, I am going to tell you that this side is 9, and this side is 15. Well, let's do something different. I think this is going to work out too easily. Let's say this side is 17. Okay. All I have is, I know I have a right triangle, and I know two sides of the right triangle. And I want to find out the sine, the cosine, and tangent of theta. Well, I know in order to do sine, cosine, and tangent, I have to label things opposite, adjacent, and hypotenuse. So I locate the angle that I have, which is right here. And I decide, I always look at what is going to be opposite. Opposite is directly across. So this side is going to be my opposite. I'm just abbreviating it. I don't happen to know it, but that has to be my opposite side. The one that's directly across from the right angle, and the right angle happens to be up here on the top now, the one that's across from it is this one. This is my hypotenuse. And the other side that's connected to the angle, the one that's not the hypotenuse, but it's still connected to the angle, which is right here, that's my adjacent side. It's always easy to figure out the adjacent if you first figured out the opposite and hypotenuse. What's left has to be the adjacent. Be very careful. I would actually on when I'm doing a test or I'm doing a homework even, when I do something like this, I always start out writing out that SOHCAHTOA, making sure I know how to spell it properly, and then labeling my triangle according to opposite, adjacent, and hypotenuse. Again, if this would have been the angle I would have been given, then I would have looked at everything from this perspective, and this would have been my opposite, and this would have been my adjacent. This would still have been the hypotenuse because it's across from the right angle. So always label your sides from the perspective, the angle that you are interested in. Okay, so we now want to figure out sine of theta. That's why I can't just write sine. I have to write sine and then the name of the angle I'm looking at. Cosine of theta and tangent of theta. So sine is opposite over hypotenuse. So it's going to be opposite. Oh, I don't know what the opposite side is. The opposite side is empty. But I know once I have two sides of a right triangle, I can figure out the third side. How do I do that? By using my Pythagorean theorem. A squared plus B squared equals C squared. I don't have to be told all three sides of the right triangle because I have a formula that allows me to figure out the third side of the triangle. Now remember, the C squared is always the hypotenuse squared. So this is going to be our 17 squared. And then we can do 9 squared plus B squared. It doesn't matter. You could do this, you could call this A or B, it doesn't matter. Though the A and the B's are interchangeable as long as you always keep the C squared where the hypotenuse is. Okay, so 9 squared is 81. B squared we don't know. And C squared, 17 squared is 289. And to find out what B squared is, I'm going to have to subtract the 81 from both sides. So that'll give me B squared equals 208. Which means that B is going to be the square root of 208. Now, when we do the square root of 208, we have to look at our questions. Sometimes the answers will be asked in terms of give your answer as a fraction in simplest radical form. And sometimes the answer will be, say, give your answer as a decimal to 3 decimal places. I'm going to do it both ways. I'm going to give you it as a fraction and also as a decimal. Now, B happens to be, if I go to my calculator and do the square root of 208, I don't get an even answer. 208 is not a perfect square, but I can simplify this radical by breaking it up into 4 and 52. Actually, I think I'm going to do 16. Let's see if 208 is divisible by 16. 208 divide 16. It does come out even. I can simplify this even more. So it'll be the square root of 16 and the square root of 13, which becomes 4 radical 13. Hint, they usually do not give you difficult examples to simplify. So in simplest radical form, the opposite side came out to be 4 square root of 16. Okay, So step number one, when we want to do this trigonometry, is to make sure we have all the sides of the triangle. If we don't have the side that we need, then we have to go use our a squared plus b squared equals c squared to find the third side of the triangle. That we've done. Now we go. Sine is opposite, which in our case is 4 square root of 13. Over hypotenuse, which is 17. In simplest radical form, my answer is 4 radicals 13 over 17. If I want to put this in decimal form, I'm just going to change, and I'm going to do 4 times square root of 13. And I'm going to put that as, if I change this to, or I could have just done the square root of 208. In decimal form, that's 14.4222. Go to 4 decimal places. So I could do this as 14.4222 over 17. And when I divide that by 17, it gives me 0.848. The next number is the 3. So therefore, I don't make this any larger. So here's my answer in radical form or in fraction form. Here's my answer in decimal form. Gonna need more space, so I'm gonna do this down here. What if the question was find cosine of theta? Well, I know what cosine of theta is, so cot is adjacent. What's the adjacent? Oh, we have it over here. It's 9 over hypotenuse. We know what the hypotenuse is. It's 9 over 17. That's my answer. It can't be reduced. This is my answer in fraction form. If I want it in decimal form, I just do 9 divided by 17. And it gives me 0.529. The next one is 4, so I just leave this. If you notice, both the sine and the cosine are numbers that start with decimal points because they're less than 1. The final one, tangent theta, is opposite over adjacent. So opposite is 4 times square root of 13. And adjacent is 9. So here's my answer in radical form. In decimal form, I'll do, well, the 4 radical, this is the 4 radical 13, we did that before, is 14.4222 divided by 9. Which gives me 1.602. The next number is a 4. If you notice, the tangent is sometimes more than 1. It starts with a whole number, where the sine and the cosine are always start with decimals. I hadn't told you what this is good for, but we have figured out how, with just 2 sides, all I gave you on this triangle was the 2 sides, 9 and 17. Of course, I told you it was a right triangle, but with that, I was able to figure out all 3 trigonometric function, sine, cosine, and tangent. Okay, I'm going to do one more before I give you one to try. Okay, I'm erasing this. I'm giving you this information. The cosine of theta is 5 over 14. Find tangent of theta. I want it both as a fraction and as a fraction in simplest form, and also as a decimal. Now, sometimes the question will be in terms of fractions, sometimes it will be in terms of decimals. You just have to read the question. Now, they didn't give me any triangle. The only thing they told me was what the cosine is. But if I remember, the cosine is adjacent over hypotenuse. And they gave me that the cosine was 5 over 14. So I'm going to draw myself a right triangle. And for convenience sake, I'm going to put this theta over here and my right angle over here. Because I'm asked to draw it, I can put it any place I want. And I'm going to draw it so that I have, since I want the cosine to turn out to be 5 over 14, I'll pick the adjacent side of the triangle to be 5 and the hypotenuse to be 14. That'll certainly give me that my cosine is 5 over 14. So let's first label our sides. Again, remember, this is my angle theta. Directly across from it is the opposite. Directly across from the right angle is the hypotenuse. And the third side, the one that's connected to the angle but not across from it, is the adjacent. So we've labeled our triangle. We know where our theta is. We know where our opposite, adjacent, hypotenuse. Now go to this. I told you I'm going to call the adjacent side 5. So I'm going to put my 5 over here. And I'm going to call my hypotenuse 14. I'm going to put the 14 over here. Notice that means that theta, the cosine of theta, is 5 over 14. So looking at the fraction, I could tell which side to put as the opposite, which to put as adjacent, which to put as the hypotenuse. Now I want to find the tangent of theta. Now tangent means toa. It means opposite over adjacent. That's what we know from knowing what the tangent is. And the problem here is I know that the adjacent side is 5, but I don't know what the opposite side is. So in order to find the opposite side, I have to use the Pythagorean theorem. Anytime I have two sides of a right triangle and I want to find the third side, I just have to do a squared plus b squared equals c squared. So I will do a squared, let's call this, plus 5 squared equals 14 squared. Just be careful again, always have the number over here being your hypotenuse. So this is going to give me a squared plus 25 equals, now 14 squared is 196. And I'll subtract 25 from both sides. So that gives me a squared equals 171. And a then comes out to be the square root of 171. Now, 171 happens to be divisible by 9. So we can write this as the square root of 9 times the square root of 19, which gives me 3 radical 19 in simplest radical form. I should try and simplify it if I can. Again, usually it's not a problem. Usually they are not simplified. Okay, so what do we want? We want to find, we know that the opposite side is 3 times radical 19. And we know that the tangent is opposite over adjacent, so it's 3 radical 19 over 5 as my answer as a fraction, an exact number. If we want it as a decimal to 3 places, well, I'll just go to my calculator and I'll stick those numbers in. 3 radical 19 divide by 5 gives me 2.615. The next number is a 3, so I just leave it like that. To 3 decimal places, it's 2.615. Okay, I'm going to give you one to try now. Okay, I'm going to draw you a picture and I'm going to ask you to do it. This is straight off of a previous final. This is the picture they gave me with the A over here. They didn't use theta, they used A, but it's a capital A, so we know it's an angle. And this side they marked 84, and this side they marked 100. And they want us to find sine A. And they gave us 4 choices. Which of these 4 numbers, A, B, C, or D, is the correct answer for the sine of A? I'm going to give you a few minutes to try that. Okay, I see that some people are coming up with answers. So let's see if we can work this out together. Okay, number one. They want us to figure out what sine A is. Sine A is SOHCAHTOA, so is opposite over hypotenuse. I have to first decide which two sides I need for the fraction. And for sine, it's so, which is opposite over hypotenuse. Well, let's label our sides. Here's my angle A that they gave me. So directly across from it is my opposite. Remember, this is my right angle. I should have put that corner here. So this is my hypotenuse. And which leaves this to be my adjacent. Always look at the angle they give you and from its perspective, figure out which is the opposite, the hypotenuse, and the adjacent. I always like to do opposite and the hypotenuse first, and then I can figure out the adjacent is the one that's left over. Okay. So this side they told me was 84, and this side they told me is 100. Now, in order to do the sine, I must do the opposite over the hypotenuse. They didn't give me the hypotenuse. So the first thing I have to do is figure out what is the hypotenuse. I have to do the a squared plus b squared equals c squared. They don't have to give me all three sides of this right triangle because I can always figure out the third side if I know two of them. And I know the a and the b, I don't know the c, so I'm going to do 84 squared plus 100 squared will give me c squared. Now, I'm certainly going to use my calculator for this. 84 squared is 7,056. 10,000 squared is, 100 squared is 10,000. That's what my c squared is. So when I add these two together, I get 17,056 is what c squared is. So to figure out what c is, I have to do the square root of, so I'm doing the square root, and I must do this on my calculator, and there's no way I can do this in my head. 17,056 gives me 130.59862. Not going any further, I don't have more room, but I could use even all of the numbers. So when I want to figure out what the sign is I have to do the opposite side, which is 84, divided by the hypotenuse, which is 130.59862. I just have to do this on my calculator. All this is going to be on my calculator. So you do 84 divided by 130.59862. And it gives me this is what I'm getting, 0.643192, etc. So this is not the right answer. I knew this couldn't be the right answer, A, because the sign always has to start with a decimal. It can't start with a number. It's not this. It's not this, 100, it's too big. This is, they rounded off to 2 decimals. I'm supposed they usually go to 3 decimals, but they only wrote 2 decimals. That was the way they wrote the answer. 0.64 would be the correct answer. Choice D was the correct answer here. Do you see why it can't be choice A? Are you okay, Dina, with this? Dina and Ariana, I see you. Again, this was your adjacent. You wanted opposite over hypotenuse. So you had to do 84 over this number, which we hadn't been given. Okay, I just want to spend, okay. I don't think what I'm going to show you right now, you're required, I think this is what you're required to know, but I want to go a step further and show you how this could be useful. We just figured out that, well, let's take this number. I figured out that the sign of A to 3 decimal points came out to be 0.643. I'm going to erase all of this and just use that information. Remember, I told you that the A squared plus B squared equals C squared helps you find the missing side of your right triangle. But we're also missing angles. We only know one angle of our triangle right now. We know that this angle is 90 degrees. We also know the other 2 angles, this A and if this is, let's say, B, are add up to 90 together because all 3 angles in any triangle always add up to 180. But I don't know, maybe this angle is 20 and this is 70, maybe this is 10 and 80. I don't know what it is. This trigonometry, this fact that we have that the sine of A is 0.643 is embedded in our in our calculator the information that goes together with the angles. That's what I can only do it with a calculator because I don't have this information otherwise. But if I go on my calculator, you'll see that there are 3 buttons on my calculator. Most scientific calculators have one button that says sine, one button that says cosine, and one button that says tangent. Again, I don't think you have to know how to use these buttons, but you certainly will need it for pre-calc. So even if it's not on our final, you still need to know this information eventually. Above the buttons, there's a sign with a little -1. This one says cosine with a little -1, and this says tangent with a little -1. If you want to find the angle associated with the sine of A being 643, what you do is you press your second button. That's the alternate or the second function button. In my calculator, it's the one right over here. Then you press your sine button. And then you put in your 0.643. And then you press enter or equal. So that's what I'm going to do now. Second, sine. Notice it comes up saying sine -1, 0.643. And I close my parentheses and I press enter. And I get something that says 40.015. It keeps going on. This is how many degrees are in that angle. Usually we round off to the nearest number. In other words, it means that angle A is 40 degrees. If you don't get that answer when you put it into your calculator, it means your calculator is not set up at the right, what we call mode. It's in a different mode, and it's giving you answers in a different than in degrees. We want to use degrees. So the sine, knowing what the sine is, allows us to find out what angle A is. Of course, now this is 40, and then the two of them, remember we said add up to 90, so this one would be 50. So the trigonometry allows you to figure out the angles of the triangle. Again, right now, all I'm requiring you to do is to be able to figure out what the sine is. But I wanted to give you an indication as to what you can use the sine or the cosine or tangent for in terms of practical purposes. Okay. I'm going to stop right here. As I said, we're going to finish this topic of trigonometry on Tuesday. We're going to talk about 3 other trigonometric values. We talked about something called a sine, a cosine, and tangent. I'm not giving you what the names of them are. You might have seen this before in your high school class, but otherwise you'll see it here. And what you're required to be able to do at this point is to find out any missing side from a right triangle. If you know 2 sides, how to find out the third side. That's a squared plus b squared equals c squared. And then how to find the sine, the cosine, and tangent of any angle once you have 2 sides of the right triangle, or any of the type of problems that we gave you. Don't forget to look out for Delta math homework. Make sure you take advantage of the remaining time, especially this weekend next weekend is going to be a longer weekend because we have Thursday off, to make sure to keep current with all your work. Your final grade depends on 25% being your midterm, 35% being your final, which both of those tests, well, the midterm you've already taken, the final is going to be 30 multiple choice questions on Blackboard. And any homework and tests that I gave you aside from that is the final 40%. The final exam is 35%. The midterm was 25%. That adds up to 60. The final 40% is from my class tests and my class, and your class participation is included in that, and your homeworks. Make sure you've done all those homeworks, because a missing homework will affect your final grade. Make sure if you're missing any tests that you make up the tests. If they're not open anymore, you've got to get in touch with me so I can open it for you, so I can give you, so that you can make up any missing work. Is there any questions that anybody has? Okay, and I will be giving you some work on trigonometry on Delta Math, just as practice of what we've done. Okay, have a nice weekend then. And I will see you on Tuesday.
Bye, Professor.
Bye-bye.